Hey there, tech enthusiasts. It's your boy Linus, back with another deep dive into the world of cutting-edge technology. Today, we're talking about something that's absolutely revolutionizing the way data centers are built and utilized: CPU-GPU integration. Now you might be thinking, Linus, why all the hype about integrating GPUs into data centers? Well, buckle up, because the answer is simple: demand. The world is generating data at an unprecedented rate, and traditional CPU-only data centers are struggling to keep up. Think about it. Artificial intelligence, machine learning, big data analytics, these fields are exploding and they all require massive computational power. CPUs, with their limited core counts and sequential processing style, just can't handle the load on their own. That's where GPUs come in, like the cavalry riding to the rescue. GPUs, with their massively parallel architecture and thousands of cores, are specifically designed to handle the complex, data-intensive workloads that modern applications demand. Integrating them into data centers is no longer a luxury, it's a necessity. So let's dive into the nitty-gritty and explore how to master this game-changing technology. First, let's understand the basics. CPUs, or central processing units, have been the brains of computers for decades. They excel at handling a wide variety of tasks, but they do so one at a time, sequentially. This sequential processing is great for general-purpose computing, but when it comes to handling massive amounts of data simultaneously, CPUs hit a bottleneck. GPUs, or graphics processing units, on the other hand, are designed for parallel processing. They can handle thousands of operations at the same time, making them perfect for tasks that require heavy computational power. This is why GPUs are so effective in data centers. They can process large datasets much faster than CPUs, making them ideal for applications like AI and machine learning. By integrating GPUs into data centers, we can achieve a balance where CPUs handle general tasks and GPUs take on the heavy lifting of data-intensive operations. This synergy between CPUs and GPUs leads to more efficient data processing, reduced latency, and ultimately, better performance for modern applications. As we move forward, the integration of GPUs in data centers will become even more critical. With advancements in AI, machine learning, and big data, the demand for high-performance computing will only grow. So, whether you're a tech enthusiast, a data scientist, or a business looking to stay ahead of the curve, understanding and leveraging GPU integration is key. Stay tuned as we continue to explore the fascinating world of high-performance computing and uncover the technologies that are shaping our future. Until next time, keep pushing the boundaries of what's possible. Alright folks, let's talk hardware. Today, we're diving deep into the heart of any computing system, the CPU. When it comes to CPU-GPU integration in data centers, selecting the right components is absolutely crucial. The CPU, or central processing unit, is often referred to as the brain of the computer. It performs the essential calculations and tasks that keep everything running smoothly. It's like building the ultimate gaming PC, but on a much larger and more critical scale. First up, the CPU. In a gaming PC, the CPU handles everything from game logic to physics calculations, but in a data center, its role is even more expansive. Now, you might be tempted to think that the GPU is the star of the show, and while it plays a vital role, the CPU is still the brains of the operation. The GPU, or graphics processing unit, is excellent for parallel processing tasks, but it relies on the CPU to manage and direct its workload. It's responsible for managing the overall system, handling data flow, and orchestrating the interaction between the GPU and other components. The CPU ensures that data is processed efficiently, and that all parts of the system work together seamlessly. For data center applications, we need a CPU that can handle the heat. Data centers operate 24/7, and the CPUs must be robust enough to handle continuous, high-intensity workloads without overheating. Look for high core counts, fast clock speeds, and support for the latest memory technologies like DDR5. These features ensure that the CPU can handle multiple tasks simultaneously and process data at lightning speeds. We're talking about server-grade processors from companies like AMD and Intel, the kind that power those massive cloud computing platforms we all rely on. These processors are designed for efficiency, reliability, and performance, making them ideal for data center environments. Think of it like this: the CPU is the conductor of an orchestra, while the GPU is the entire string section. The conductor ensures that every musician plays their part at the right time, creating a beautiful symphony. The conductor might not be playing every note, but they're essential for keeping everything in sync and delivering a harmonious performance. Similarly, the CPU might not handle every single task, but it ensures that all components work together efficiently. So don't skimp on the CPU, choose wisely. Investing in a high-performance CPU can make a significant difference in the overall efficiency and reliability of your data center. Remember, the right CPU can handle complex tasks, manage data flow, and ensure that your entire system operates smoothly. So next time you're setting up a data center or even a high-end gaming rig, give the CPU the attention it deserves. It's the unsung hero that keeps everything running like a well-oiled machine. Now let's talk about the heavy lifters, the muscle cars of the data center world, GPUs. These bad boys are where the magic happens when it comes to accelerating those data-intensive workloads. Choosing the right GPU depends heavily on your specific needs. For AI and deep learning, you'll want to go for GPUs with tons of CUDA cores and massive amounts of high-bandwidth memory. Think NVIDIA's A100 or H100, the behemoths that are pushing the boundaries of AI research and development. If you're dealing with high-performance computing applications like scientific simulations or financial modeling, GPUs with a focus on double-precision floating-point performance are your best bet. AMD's Instinct. MI200 series is a prime example, packing enough computational power to make even the most demanding scientists drool. Remember, GPUs are not one-size-fits-all. Factors like the type of data you're processing, the algorithms you're using, and your budget will all influence your decision. Do your research, compare specs, and choose the GPU that best aligns with your specific workload requirements. We've got the brains, CPU, and the brawn, GPU. But what about the fuel that keeps this high-performance machine running smoothly? The answer lies in memory and storage. That's where memory and storage come in. They are the unsung heroes that ensure our systems operate at peak efficiency. In the world of data centers, RAM is king. It provides the necessary speed and capacity to handle large datasets and complex computations. And when you're dealing with GPUs, which are designed for parallel processing and heavy computational tasks, you need a king's ransom of it. The more RAM you have, the better your system can handle multiple tasks simultaneously without bottlenecks. Look for high-capacity DDR5 DIMMs with fast speeds and low latencies. These modules are designed to meet the demands of modern computing environments. The more RAM you have, the more data you can feed to those hungry GPUs, ensuring they operate at their full potential. This is crucial for applications like machine learning, data analysis, and real-time rendering, where performance is key. Keeping them crunching numbers at their full potential means faster results and more efficient processing. Storage is another critical aspect. While RAM handles the immediate tasks, storage is where all the data resides. Traditional hard drives are simply too slow for the demands of high-performance computing. We need something faster, something more responsive. That's where NVMe SSDs come in. These solid-state drives offer significantly faster data access speeds compared to traditional hard drives. These blazing fast storage devices use the PCIe interface to deliver lightning-fast data access speeds, ensuring that your GPUs are never starved for data. This means quicker load times, faster data retrieval, and overall improved system performance. Think of it like this. RAM is like your immediate workspace where you keep the tools and materials you're actively using. It's where the action happens, where data is processed and computations are performed in real time. Storage, on the other hand, is like your warehouse, where you store all your raw materials and finished products. It's the long-term memory of your system, holding everything from operating systems to application data and user files. Both are essential for a well-oiled operation. Without sufficient RAM, your system would struggle to keep up with real-time demands. Without fast storage, data retrieval would be a bottleneck. Together, they ensure that your high-performance machine runs smoothly and efficiently, feeding the beast with the fuel it needs to perform at its best.